Lecture 25, summary and farewell. Woo! All right. Yeah. So let's jump right in. One of the exciting things about being in CS10 is it's just the tip of the iceberg of all the million things you can do with computing. I mean, there really are a million different things that you can use computing for, either for computing's sake or to solve one of the world's problems. And it's really, really exciting. So we are going parallel. The idea of how do you program a million machines? How do you program a whole cloud of computers to do some huge computation is a really, really hard problem. We've been trying to kind of dig at that big rock, and we haven't really solved it. So that's an unsolved problem, and we're still working on it. So that we need people to work on that as well. The applications, you're going to have, computing's going to play its role in the following. You're going to have basically supercomputer computing power at your fingertips. Not only because the little iPhone and Android processor is already faster than many supercomputers were 20 years ago, but we're at a post-PC era, which means your little device is really not the computing piece of it. It will allow you to connect to a web, to the cloud, and then there is the whole thing. So often you'll have this amazing service, like how is it able to do speech recognition? What it did was took that sample, sent it to the cloud, did the recognition on the cloud in 10,000 machines, and had the answer come back to you. So basically, through that smartphone connected post-PC model, you have access to all of the world's computing powers, and that's unbelievable. What would you do? What could you do with it? And all these apps are coming up that are basically taking advantage of the fact that there's so much power out there that you don't have to have locally, and that's an amazing model. So you can imagine on your body health monitoring where you have a virtual body double and something happens. Oh, you got an injury. Somebody punches you, and all of a sudden your computer says, do-do-do-do. Okay, you got punched. Okay, that means there's probably some swelling. It'll know. It'll actually tell you, do-do-do, quick, put some cooling on it. What if you happen to have, it might even look at what you're eating. You were talking about Google goggles. It might even look what you're eating and saying you're now taking in, I've estimated that's now an additional 35 calories. Don't take the bus. You got to walk to work now to burn that off. That's exciting. You now already have the library congress on your PDA. That was a big deal. Like, oh, how much storage could you store locally? But the reality is you have the cloud. You have Wikipedia. You have all these things. You can just ask Siri, and Siri will get the answer for you. What does that mean for the future of learning? Why are we still doing things the old way when you actually have access? It's like, not it's a calculator, you have the whole world there. Why are people still writing when they can type anything and when you have speech recognition? You know, I'm starting to ask questions of how much of what my son, who's now in first grade, what he's learning is actually outdated already. Why is he learning how to print? He can be messy, but everyone types. I haven't written something in a year. I type everything. So, or I say da-da-da-da, and it prints out. Like, why does even learning how to write important? All these things are really fascinating to me. Maybe you need that one. Okay, but the point is, there are things that he's going to be doing for the next 12 years of high school and junior high and grade school that you may not really need anymore thanks to this tremendous paradigm shift of computing being everywhere and available everywhere. It's amazing. So HCI, Bjorn's lecture, Professor Hartman's lecture was incredibly relevant. HCI is so critical as you go forward because every time you interact with a computer, there's a human-computer interface designer who made that seamless or hard. Many of you have had, you call up the company and there's an online robot talking to you and you say, representative. He goes, I don't understand that. I'm saying representative. I don't understand that. That's like the most frustrating HCI element there is. And there's some that are just really transparent that you say, I'd like to book a flight to Rio at 7 o'clock tomorrow. I think you just said you want to book a flight to Rio at 7 o'clock. Oh my gosh, that worked, and that was a computer. So some of the time it's really wonderful and really fluid. You probably had, you play with the iPad and just felt like so fluid, these interfaces. People are doing really great jobs with HCI elements in all the aspects. The Connect is now a reality of why can't I be doing this to, I want to get a taxi. If I just go like this, shouldn't there be some computer that says, like, if in my office is watching me, I go like this, like I'm hitch a cab, all of a sudden, yep, the taxi's waiting downstairs. It just knew that this meant get a taxi downstairs. All those things are incredibly cool. So exciting stuff, very exciting. Here's why, okay? And here's the person who's going to do it at the Berkeley campus. I believe that the matrix-like input to the system where you can think something and it just happens is incredibly powerful. And people are already exploring that. He's exploring it in the context of people who have, like, say, lost a limb. And you want to be able to control a robotic hand to do that. So that's a really relevant problem for bioengineering. And he is working on the brain-machine interface. It's not a game. There are macaw, M-A-C-A-U, macaw monkeys who, they don't cut their arm off, but they pin the arm down, and then they actually go in and they put probes, and the monkey can control a hand to feed itself. Do you guys realize this? The monkey thinks, hand out, it doesn't move its body, hand out, okay, open the fingers, grab banana, feed myself. And the monkey's gotten good at feeding itself a robotic arm. Okay? That's the beginning, folks. That's the beginning of this brain-machine interface that's tested out, again, on animals to build up. But I think I would stand up and be one of the first people to do this. I cannot wait to be able to connect a computer fast. Think a number and it happens. I mean, imagine you have the Project Glass output and a brain interface. I think, send a message to Luke. Beep, 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 sent. And I see it. Like, my hands didn't move. That's incredible, right? That is really, really incredible. I can't wait to see what they come up with next. What's the future what's the future for you? I've already talked about you're in a world where it's the post-PC era. You've got cars that drive themselves. You've got the whole web on your smartphone and in your goggles. Well, you've got quantum computing coming around the room. That's going to blow. If quantum computing ever hits, it's going to blow up, folks. Ubiquitous computing means you have computing power everywhere as much as you want. Volunteer CPUs, people volunteering their own workstations to help with some big problem. Rapid changes of technology, voice input. Just in the last year, voice input has taken us to creative things. The world's, and I wrote second best education, because a couple of years ago we were rated number 2 in the whole world, so it's world's second best education in the whole world. Never give up. This is a Cal philosophy, never give up. If you get struggled, you're going to push through. Cal is all about staying through. Alan Kay, a good friend of mine, says, the best way to predict the future is to invent it. And it really is the case that you guys are going to be making the future, whether it be a company or grad school or working and being a teacher. Whatever you do, you guys are going to make the future. It's exciting. The future's up to you. So I want to thank you for the privilege of teaching you guys. You guys are awesome. And I will see you at the party. Woo! Go CS10.